Welcome to the deep dive. Today, we're undertaking, well, a pretty surprising intellectual journey, I think. We're connecting thinkers who first questioned reality itself, the pre-Socratics, directly to the most advanced AI architectures we have today.
Yeah, it sounds almost like science fiction, doesn't it? Intellectual time travel. But our sources show there's this genuine, ongoing dialogue
Right.
between ancient philosophy and modern machine learning. Researchers like Gerardo Giovanni and Giovanni Oven, they argue that when we design AI, we're actually kind of by necessity engaging with these really fundamental philosophical questions.
Questions about what exactly?
About cognition, about reasoning, learning itself, the big stuff.
Absolutely. So the machine learning stack you see today, it isn't just like applied maths.
Not at all.
It's built on millennia of debate about what knowledge even is and how we get it. So our mission for this deep dive is really to unpack how these philosophical debates about change, reality, structure are kind of the theoretical blueprints for building AI systems.
Systems that need to be adaptive, trustworthy.
Exactly. And context sensitive. So let's maybe start at the beginning of modern AI and see where it first, ran into a philosophical brick wall.
Okay. Yeah, that takes us back to the early days. Symbolic AI.
Right.
This whole approach was based on what's called the information processing assumption. The idea was, pretty straightforward on the surface.
Which was?
If human intelligence uses logic and rules, maybe we could just mimic it perfectly by designing systems that manipulate formal symbols and rule sets.
Very neat and tidy.
Exactly. It was appealing because it felt clean, precise, purely rational.
But life isn't neat and tidy, is it?
Definitely not. And the real world needed something symbolic AI just couldn't provide, which was context.
Context, okay. So who pointed this out?
Well, Joseph McClure really highlighted this failure point. He argued these symbolic AI systems were just too restricted.
Oh, so?
They completely lacked intuitiveness. And that context-sensitive reasoning we rely on, they could maybe solve a formal logic puzzle, sure.
But not the messy stuff.
Right. They couldn't handle complex, ambiguous expertise like, say, being a master chess player who relies more on pattern recognition than calculating every single move, or even just doing a basic real-world task.
Yeah, okay. And philosophy weighed in here too, didn't it?
Oh, definitely. Philosophy came in with a pretty devastating critique, led by Hubert Dreyfus.
Dreyfus, what was his argument?
Dreyfus argued that when a human becomes an expert, think of a surgeon or an experienced driver, they actually stop relying on context-free, step-by-step rules.
So they aren't running through a checklist?
Not consciously, no. Instead, they're seeing a new situation as somehow similar to a previous one they've encountered.
Recognition.
Exactly. And they instantly apply a successful plan from before. It's recognition, not just computation. Symbolic AI just had no mechanism for that kind of fluid, implicit knowledge.
That distinction rules versus recognition, that must have caused a huge stir in the field.
It did.
Was there a specific technical problem that really drove this home, that showed the systems themselves couldn't cope?
Yes, there was. It became known as the frame problem.
The frame problem. Sounds ominous.
It was a technical nightmare, really, and it stemmed directly from that symbolic approach.
How did it work? Or rather, how did it fail?
Well, since the system had to use explicit rules for absolutely everything, if you gave it a new scenario, it literally couldn't figure out what information was relevant and what was irrelevant quickly enough.
Can you give us an analogy?
Yeah.
Because that sounds, incredibly inefficient.
Okay, imagine you tell a symbolic robot, move the cup from the table to the sink.
A simple enough task, you'd think.
Right. But for this robot to actually function, its programming has to check every single variable in its known universe before it can act.
Every single one.
Pretty much. Is the cup still on the table? Okay, yes. But it also has to check, is the sky still blue? Wait, is the sky green now? Is gravity still working? Are all the books on the shelf still red?
Oh, wow.
It has to consider or frame every possible variable to make sure no background condition, no rule has unexpectedly changed.
It sounds like it would just freeze.
It practically did. It just couldn't handle the massive amount of irrelevant context in any new situation without getting stuck in this potentially infinite loop.
Yeah.
The search space just exploded.
So, okay. It couldn't replicate that flexible sort of implicit knowledge humans have.
Right.
And then it also hit this technical brick wall with the frame problem.
Exactly. Those two things combined basically forced a fundamental shift. away from the purely symbolic paradigm.
Towards what we see more of now.
Towards probabilistic methods, data-driven approaches, neural networks, systems that could actually learn from patterns in data rather than needing every single rule spelled out explicitly.
Okay, so that brings us more up to date. And the big challenge then became what? How to blend these approaches.
That's it, exactly. The fundamental paradox, you could say, of modern AI became, how do we get the robustness of that old symbolic logic and the flexibility of the new data-driven neural networks? We wanted the best of both worlds.
It sounds like the AI community had to admit that maybe neither pure approach was the whole answer. And that maybe.
Yeah.
Philosophers had actually been arguing about similar kinds of trade-offs for centuries.
Precisely. Vadinsky highlights this really beautifully. The solution that emerged was these hybrid cognitive architectures.
Like Clarion.
Like Clarion, yes. These systems are, I think, inherently philosophical because they embody this understanding that human cognition isn't just one thing. It's multi-layered, it's context-dependent.
So they merge the two.
They merge symbolic manipulation, the rules, with connectionist adaptation, the learning from data. You're literally building a machine that tries to combine. Well, the two great schools of thought in Western philosophy about where knowledge comes from.
You mean rationalism and empiricism?
Exactly. This dual system approach, it's like a tangible manifestation of combining a rationalist view knowledge through innate structures and rules with an empiricist view knowledge through sensory experience and data.
Okay, that's a powerful idea. So what specific technical problems did this philosophical merger actually manage to solve, or at least address?
Well, it was crucial for tackling a couple of really key challenges. First, it offered a pathway to deal with a very deep philosophical hurdle called the symbol grounding problem.
The symbol grounding problem. Okay, that sounds important. What is it exactly?
Yeah, it's fundamental. The problem asks, how does an abstract internal symbol inside the AI, say the token or the word dog, actually get any meaning?
How does it connect to a real dog?
Exactly. How does it relate to the furry, four-legged thing in the real world? If the symbol isn't grounded in some kind of experience or real-world connection, it's just empty manipulation, like a student solving an algebra problem without having any clue what X or Y actually represent in the real world.
Just shuffling symbols.
Just shuffling symbols, yeah. Meaningless.
So the hybrid system helps ground those symbols. How?
Yes, and that leads to the second key feature, creating what we call semantically enriched systems. The explicit rule-based knowledge, like the symbol for dog, gets refined and enriched empirically by these things called neural embeddings.
Neural embeddings. Those come from the neural network part.
Right. They're basically complex numerical representations that the neural network generates as it processes, say, millions of images of actual dogs, or sounds of barking, or text about dogs.
So it connects the abstract symbol to the patterns learned from real data.
Precisely. It gives the symbol real-world context and essentially meaning. And this robust blend allows the system to make sense of new things it encounters, adapt its internal rules, and then categorize that new input to inform better decisions later on.
It's fascinating that the technical solution seems to echo these long-standing philosophical debates.
It really is.
Now, you mentioned the source of these ideas goes back even further than rationalism and empiricism.
That's right. Vernon and Furlong, for instance, suggested that the foundational principles in a lot of current cognitive AI systems, they actually originated in debates stretching back over millennia.
Millennia.
Yeah. When we talk about designing adaptive machines today, we are, often without realizing it, engaging with concepts that worried the very earliest known philosophers. We're talking deep history here.
We mentioned the pre-Socratics at the start. How does someone like, say, Heraclitus, writing around 500 BC, how does he actually connect to a cutting-edge AI algorithm?
Well, it comes down to the fundamental question that Heraclitus wrestled with, the nature of change.
Change is the only constant, that Heraclitus.
That's the one. He famously argued, you cannot step into the same river twice. This view of the world as being in constant flux, always changing, that directly informs the need for adaptable connectionist systems in AI.
The ones that learn from data.
Exactly. By contrast, think about that earlier symbolic AI, trying to operate by rigid, context-free, unchanging rules.
Right.
It was essentially embodying the opposing philosophical viewpoint, Parmenides' belief in stasis and permanence, that change is an illusion.
Wow, that is a stunning parallel. So the failure of early symbolic AI was kind of like a philosophical failure. Parmenides' view hitting the wall of Heraclitus' flowing reality.
You could absolutely frame it that way, yes. Modern hybrid AI, which embraces adaptation and constant learning from new data, is fundamentally operating in a Heraclitean world.
And the influences don't stop there.
No, the lineage is clear. You've got the pre-Socratics grappling with change, then Aristotle's theories on causation and how we categorize things, then Kant's ideas about how our innate mental structures organize experience. All these provide the theoretical scaffolding that lets us combine data and rules meaningfully today.
So philosophy isn't just ancient history for AI.
Not at all. It's continually providing insights and challenges. Think about debates on embodied cognition, the idea that intelligence needs a body interacting with the world. That continues to challenge AI design, often building on critiques like the one Dreyfus made years ago.
Okay, so if the intellectual framework for AI is this deep and, frankly, this ancient, what does that mean for the very modern concerns around things like reliability and epistemic trustworthiness? These are huge issues today, ethically and practically.
They absolutely are massive concerns. And interestingly, the way AI needs to handle those concerns is, in itself, a kind of philosophical process. Well, take retraining and optimization. Ferrario makes this a really fascinating argument. These common AI processes, they actually mirror what philosophical systems have always done.
Which is?
Adapting. Adapting in light of new observations, new evidence, or maybe adapting to achieve better goals. Thinkers refine their theories based on new arguments or data.
Okay, so when a developer retrains a machine learning model because, say, it started performing poorly, or maybe the environment it's operating in changed, we shouldn't just see that as a technical fix, like debugging code.
Ferrario suggests we shouldn't know. We should rethink AI retraining as something more profound, a metaphysical and ethical necessity.
Metaphysical and ethical, that's strong language.
It is, but think about it. If an AI system is designed to operate in the world, and the world fundamentally changes, which, going back to Heraclitus, it always does, then doesn't that system have a kind of, well, maybe a moral obligation to adapt its behavior?
If it doesn't adapt.
Then its utility breaks down, its predictions become wrong, its trustworthiness degrades. So adaptation isn't just a feature, it becomes an intrinsic, necessary component of its ongoing existence and function.
That is a really profound shift in perspective. Okay, so if retraining isn't just technical but ethical, then these systems need some serious guardrails, right? Accountability mechanisms.
Absolutely. Which leads directly to concepts like trustworthiness contracts.
Trustworthiness contracts, what are those?
They're essentially mechanisms, could be formal or technical, designed to specify the properties and boundaries that the system must respect throughout its operational life.
Like setting the rules of engagement for adaptation.
Exactly. They help ensure accountability and reliability by establishing clear expectations up front. They create an ethical framework for the AI's adaptation process.
And crucially, I guess, that framework has to understand time, because time isn't always stable or predictable in the real world.
Precisely. Nunn pointed this out very clearly. If you have machine learning models operating in temporary contexts.
Like what? Give me an example.
Think about, say, a highly specialized AI deployed to help manage the response to a sudden natural disaster. Or maybe an AI used in a temporary joint venture between two companies that will only last a year or two.
Okay, short-term situations.
Right. In those cases, the AI requires the integration of temporal awareness right into its core ML pipeline. It needs to understand its own lifespan, in a way.
Why is that so critical?
Because the AI's learning rate, its definition of what constitutes trustworthy behavior, even how it weights past data versus new data, all of that can change drastically based on its expected operational duration and the specific context.
So an AI supporting, say, a year-long construction project needs to be built differently than one embedded in some 50-year-old government bureaucracy.
Fundamentally differently, yes. The short-term AI needs to prioritize rapid reconfigurability, quick adaptation, high context awareness, much more than the long-term one might. The model has to, in a sense, know it's temporary.
It needs to be acutely aware of its own temporary nature.
Yes, that deeper integration of temporal awareness into the architecture makes sure the algorithms are optimized not just for raw accuracy, but for rapid adaptability within those specific, often fleeting boundaries.
Wow, what a fantastic circle we've kind of closed here. We started with the failures of early symbolic AI, which turned out to be fundamentally philosophical failures. And we end up with today's most complex systems needing these deeply philosophical considerations, intentionality, adaptability, temporality, just to function reliably and ethically.
The interdisciplinary synergy is just, well, it's undeniable, isn't it? Philosophy provides these essential foundations. It helps us tackle everything from the symbol grounding problem to the ethics of retraining to the nature of change itself.
It really is the bedrock.
It's the bedrock for building AI that has characteristics we often think of as human-like.
Yeah.
Flexibility, reliability, maybe even a kind of artificial intentionality. You simply can't engineer knowledge without first grappling with the fundamental questions of what knowledge actually is.
So as you, our listener, look at the next wave of generative models, all the constant rapid evolution in AI,
Yeah.
just remember that the foundational questions about meaning, representation, change the very questions debated by thinkers like Heraclitus and Parmenides thousands of years ago.
They haven't gone away.
They haven't been solved by technology.
Right.
In fact, you could argue that every technological leap just demands that we apply philosophical criticism in newer, maybe even more rigorous ways.
The faster we seem to build the future, the more, perhaps, we actually need to rely on ancient wisdom to understand the implications of what we're creating.
Definitely something profound to chew on until our next deep dive.